So, in the last class we have studied about type 2 fuzzy sets, then type M fuzzy sets, okay, intuitionistic fuzzy sets, etc. I hope you have understood what is type 2 fuzzy sets. So, today we will study operations on type 2 fuzzy sets. Operations for type 2 fuzzy sets. So, I hope you remember what is type 2 fuzzy set. Type 2 fuzzy set, and also we have done in the last class about the extension principle. Okay, that was very important to proceed with these all type 2 fuzzy sets and further studies. Okay. So, here these operations for type 2 fuzzy sets actually is done through extension principle. Okay. And we know that in type 2 fuzzy set, a set is a type 2 fuzzy set when its membership function is a type 1 fuzzy set. Okay. Then we also define type M fuzzy set, so that its membership function is of type M minus 1. Okay. So, with this we will define some operations, namely union and intersection. Okay. So, let A bar and B bar are two type 2 fuzzy sets. So, then we will try to define what are your A bar union B and A bar intersection B bar. Okay. So, as I told that it will not follow the same rule of type 1, because due to that, because its membership function now is a fuzzy set, actually it is a fuzzy set. So, now if A bar and B bar are two type 2 fuzzy sets, I can write this A bar as x mu A bar x, but remember this mu A bar x is now not a constant, because we have assumed that A bar is a type 2 fuzzy set. So, this mu A bar x will again a fuzzy set. Okay. So, that I will define, but let me write like this, and B bar may be x mu B bar x. Okay. These are two type 2 fuzzy sets. Now, where this mu A bar x, where mu A bar x will be ui and mu ui x, such that x belongs to x and this ui and mu ui belongs to 0 1. Okay, you have understood. Now, mu A bar x, because it is a type 1 fuzzy set, so ui and mu ui x I have written. So, ui is the membership degree of type 1 fuzzy set, membership grade, and mu ui is the membership for ui. Okay, that means it has 3 components, x and these 2 for different x. Okay. Similarly, I can write mu B bar x is equal to vi mu, sorry, I should change this to vj, okay, vj mu vj x, such that x belongs to x and vj mu vj belongs to 0 1. That means those are the values in the interval 0 and 1, including 0 and 1. Okay. So, that is why these two sets are type 2 fuzzy sets. So, with this in mind, okay, we will now define first what is the intersection of these two type 2 fuzzy sets. Okay. So, let us do for intersection first, and this will be done through the extension principle that we have already read in the last class. Okay. So, by the extension principle I can write this intersection of A and B, and I told that main is the membership function. So, we will write the membership function. So, I can write this intersection of this at x, okay, mu A bar intersection B bar at x, that is the membership function for A bar intersection B bar, and this will be nothing but mu A bar x intersection mu B bar x. Okay, and it will be, I will introduce another variable, that is w, okay, and mu A bar intersection B bar w, such that this w is the minimum of ui vj, and remember this ui vj belongs to interval 0 1. Okay. So, now what is this w? Because now you see this intersection I very simply wrote as one element w and its membership function, but I have to find what is this, and w is actually minimum of ui vj, minimum of ui vj. I will take example, then it will be more clear. Okay. So, what is the minimum of that? That is w, okay, and this is what, where mu of A bar intersection B bar w. Now, we will use the extension principle here, there, that sup one, the supremum we used in the extension principle. So, sup or supremum, where w is equal to that one minimum of ui vj, sup of minimum of what? It should be mu ui and mu vj. Understood? Mu ui mu vj. So, this is your membership function for A bar intersection B bar. Okay. So, first we will find minimum of these two, that is w, and then sup on this with minimum of mu ij and mu vj. Understood? That will be your intersection membership function for A bar intersection B bar. Okay. Let me write the union also, then we will take one example for the both the cases. Okay. Then it will be more clear. So, remember this set two type 2 fuzzy sets, then again I am writing for union. Union of two type 2 fuzzy sets, again A bar and B bar. So, there here similarly I will write mu A bar union B bar of x is equal to mu A bar x union mu B bar x. Okay. Same we will write here is equal to w and mu A bar union B bar w, such that w now will be maximum of ui vj. Okay. Where mu A union B bar w is supremum of w is equal to maximum of ui vj, and no, there it is changed, it will be same minimum. Okay. Minimum mu ui mu vj. So, these are the two definitions for the intersection and union respectively. Okay. Now, let us take one example how to find for type 2 fuzzy sets these two operations. Okay. So, let us take the example as, let your first type 2 fuzzy set is your small integers, okay, and B bar is your integers close to 4. These are two suppose type 2 fuzzy sets. Okay. So, we need then its mu ui and uij, its vj. No, it's what we need. See, here we need ui and mu ui. Here we need vj and mu vj. Okay. Suppose these are given. and for maybe I equal to 1 to 3, okay. So let us, so given we have I ui mu ui and I want to find the A bar intersection B bar mu of that at a point x, okay, at a point x that I want to find, and suppose x is equal to 3, okay. At x equal to 3 I want to find this mu A bar intersection B bar at x, x is 3. So that is why here it is given mu ui 3, then Vj and mu Vj 3. So these are given as for 3 values 1, 2, 3, 0.8, 1, 0.7, 0.5, 0.6, 0.4, 1, 1, 0.8, 0.5, 0.7 and point. So these are the given membership functions, okay, ui mu ui 3, Vj mu Vj 3, okay. Now this A bar will be what? This A bar will be x mu A bar x, and where this mu A bar x is what? X means 3. I have taken x as 3. 3 will be is equal to, we had, if you remember, we had written uij and mu ui and mu ui, and I told I equal to 1 to 3 given. So that means it has 3 members. So first one is u1 mu u1 at 3, u2 mu u2 3 and u3 mu u3 at 3. And if I want to write in more explicit form using this, so what are this? 0.8, 1, 0.7, 0.5 and 0.6, 0.4. So you are understanding? Similarly, I can write for mu B bar 3, that you can write yourself, okay, very simple. Now I have to find, remember, mu A bar intersection B bar at x, okay. So I have to follow those definitions that I have already written. So let us erase something. So here I am erasing this, okay. Now I have to make a table ui Vj. Remember, I want to find intersection. So in both the places it is minimum, if you remember, okay. So minimum ui Vj, mu ui mu Vj and minimum mu u I mu Vj. So these are actually at 3, okay. Okay. Now let us start with u1. So u1 is your 0.8. For this 0.8 I have mu ui as this. So it is 1, again 0.8, it is 0.5, 0.8, it is 0.4. Is it okay? Fixing u1, you are varying Vj, okay, v1, v2, v3, so 1, 0.5, 0.4. Take minimum of this, 0.8 and 1 it is 0.8, 0.8, 0.5 it is 0.5. Is it okay? Oh sorry, that is why I was, yes. Vj is 1.807, these are all mu ui, yes, sorry, 1, 0.8, 0.4. So then it is 0.8, this is also 0.8, this is 0.7, okay. Is it correct? Similarly, mu ui3, it is 1. So let me write like this, 1, and then these are the values 1, 0.5, 0.3. Am I correct? 1, 0.5, 0.3 for this one. So, minimum of these are 1, 0.5, 0.3. Is it okay? Now, next you take 0.7. For 0.7 again I have the values as 1.8, 0.7, 1.8, 0.7. So, it is 0.7, 0.7. Is it okay? Minimum of this 0.7, 0.7, 0.7. Now comes mu ui2. Mu ui2 are 0.5, 1, 0.5, 0.3. Okay? So, these are 0.5, 0.5. So, this is your 0.5, 0.5, 0.3. Is it okay? Next is your 0.6. Again 1, 0.8, 0.7. Okay? So, we have 0.6, 0.6, 0.6 and 1, it is 0.6, it is 0.6, this is 0.6. Okay? 0.6, 0.6, 0.6. Next is 1, 0.5, then 0.4. 0.4, 1, 0.5, 0.3, 0.4, 0.4. So, minimum is 0.4, 0.4, 0.3. So, this completes the table. Now, I have to use those definitions. So, I am just erasing this. Now, you see our definition is first W and mu A intersection B W, where W is minimum of ui Vj. Okay? So, now you see I have to now see where these 0.8s are there, then 0.7, 0.6. So, these are the separations. Okay? Means I have to find supremum at W is equal to 0.8. Okay? That will be your what? First value of mu A intersection B or not. So, mu, so I can have sup W or 0.8 is equal to W. Then we have minimum of sup of minimum of mu u I and mu v j. Now, you see 0.8 minimum is 1 and this is 0.5. I have to take minimum of these two. Understood? So, this will be your, so I have 1.5, no, these are the minimum values, then I have to take sup from here. I have to take sup from here, that is your 1. Understood? W value is your 0.8 and its membership value is 1 for the first one. Okay? Similarly, I have 0.7, sup 0.7 is equal to W, and see what are the values 0.5, 0.5, no sorry 0.3, 0.5, 0.5, 0.3, 0.3, 0.5, 0.5, 0.3, 0.5, 0.5, then 0.3. What is the sup? 0.5. Okay? Only remained with now 0.6. Okay? So, that I can write as sup of 0.6 is equal to W and 0.4, 0.4, 0.3, 0.4, 0.4, 0.3, and this is nothing but. So, understood? So, then we have the membership values or for the intersection. I can write this now mu A intersection B bar, A bar B bar, and at 3 is equal to, because I had taken 1, 2, 3, so 3 components will be there. So, those are, first one is 0.8, 1, okay, second one is 0.7 and 0.5, and last one is 0.6 and 0.4. Okay, understood how to find? Clear? So see, here I found for x is equal to 3. Remember this set, a bar was a small integer, b bar was integer close to 3 or 4. So I can have 4 also, I can have 5, 6, it depends upon the universal set what you are taking. So in this way I can generate all those depending upon your these membership values. Okay. So here it is given, but intuitionally in intuition you can take this, means actual problems you can take this also. This is user defined, these are values, these values. Okay. Similarly I can do for union also or not. If I want to find membership values of mu a bar b bar at 3. See, from this table only I can do, only change will be here, I am doing on the same table maximum. Okay, only I am erasing these things, these only change or not. Very simple, 0.81 will get what? 1, 0.8, 0.8. Okay, is it okay? Here it is 1, 0.8, 0.7. Okay, then this is 1, 0.8, 0.7. So others will be same or not? Is it same? But here you see now how many values of W? Again 3 values, 0.7, 0.8 and 1. But there it was in a sequence, but here you have to see, first of all suppose I want to find 1, so I have to see this and this corresponding values here. Okay. For 1, 1, 1.5 and 1.4 I have to take soup among these, so soup will be what? 1. Okay. So I can write directly or not? So I can write mu of a bar union b bar at 3, 1, because I have 3.7, 0.8 and 1. So for 1 we got 1. Okay. Now 0.8, 0.8, 0.5, 0.8, 0.3, 0.8, 0.5, 0.8, 0.4. So what is the slope? 0.5. So it is 0.5. Last is 0.7. Last is 0.7. So 0.7, 0.7. So this is your 0.3, 0.3. So 0.3. So this is your union. So in this way I can have the union intersection for type 2 fuzzy sets. And as I told you in the last class that if we increase type 4, type 5, type 6, there are, but physically you may not visualize that, because in dimension, n dimension space also, what is 10 dimension? 11 dimension, only you think okay 10 dimension means 10 elements will be in the vector, but you cannot visualize physically. Up to 3, 4 I can define. Okay. Similarly here also, so let us put up to type 2 fuzzy sets, but you should know the definition of type M fuzzy set whose membership function are of type M minus 1. Okay, clear? Okay, can I erase? So here all those associativity, commutativity, idempotent etc. are satisfied by these type 2 fuzzy sets, but that distributive property is not satisfied. Okay. So those things I will not do, just for your knowledge I am telling. Similarly I can have for different value of x also, okay, 3, 4 or whatever depending upon your membership functions. Okay. Now let us come to the next section, that is relation. Relation you have read, earlier relation you have read or not? Crisp relation. How you define crisp relation? This is subset of A cross B. That means it is a Cartesian product. Suppose I have an universal set X. I am first telling about the crisp, okay? Universal set X and universal set Y. So, we define relation as X cross Y, okay? And we define like this X Y such that X Y such that X belongs to X and Y belongs to Y, or X Y belongs to X cross Y. Okay, this is the definition for crisp relation. But we define actually relation as how? Relation, this crisp relation, if I write relation, we define in terms of chi actually, chi X cross Y, or in fuzzy term I can write it in terms of mu also, mu of X cross Y. So, let us write chi for crisp, okay? Chi X cross Y at X Y. So, relation in crisp set, okay? So, this is X Y is equal to 1 when X Y belong to X cross Y. This you know, and 0 when this X Y does not belongs to X cross Y. That means R is what actually? This R is a mapping from X cross Y to 0 1. Again you see what you are telling, relation, this is called exact relation or exactly related, and this is this means 1 and 0 means no relation. So, what is the relation between you and your niece? I should give 1 or 0, but it is not actually your full relation or not. But see, the means the philosophy here, either you have full relation or no relation, but we may have in between relations also. When you have some friend, boy or girl, so starting relation is starting from 0, 0.1, 0.2, 0.3, 0.4, 0.8, 0.9, 1, full relation or not. So, see the fuzziness, it is coming, na? Slowly it is going. So, anywhere relation is temperature and pressure. Temperature and pressure, suppose there is something which governed by temperature and pressure. So, temperature is one relation, pressure is another event. So, what is the relation between that, so that your output depends upon that? You are understanding? So, here it is a problem actually to handle actual practical problem. You are understanding why I am telling? In social life also, in engineering problem, in mathematics problem, everywhere. So, you have only if it is there, then 1, otherwise it is 0. So, what about the other things? Okay? That is why it is very important, again fuzzy relation. So, let me tell more about this, remember this, okay. So, if I have these things, all I am telling about the crisp, I have X, I have Y. Suppose I have X elements at A, B, C, and Y suppose I have 1, 2, 3, okay, A, B, C, 1, 2, 3. Suppose A is related to 1, 2, 3, this way I can draw the diagram, 1, 2, 3, 1, 2, 3. So, in this way, that means if these are related, so I have the values as 1. So, I can write the relation matrix. Relation matrix. So, relation matrix for crisp set R is what? You see, I have A, B, C and here 1, 2, 3. Okay? A is related here, it is 1. 1, 1, all are 1. If I remove any arrow, so those will be 0. Suppose I remove A to 3, that means A to 3, this is your 0. If I remove B to 1, this will be 0. That means either you give the connection or not give the connection. You are seeing? Okay? So, if I say that you just little bit minimize this means strength of this light, can you do that? Either on or off. But there are now apparatus you can reduce that. You are understanding? So, that will be, but if it is on and off, 1 or 0, binary. Okay? So, this way I can handle the strength of the relation, how much strength is there, and that strength actually your membership degree or membership function for your fuzzy relation. Here strength is either 1 or 0. Understanding? I cannot have 0.5, cannot have 0.1. So, but in fuzzy I can handle that. Okay? You are understanding? So, next let us come to, now you have little bit understood crisp relation. Whenever I will do, I will just correspond with crisp one, so that you will understand. Huh? Okay? So, now fuzzy relation. So, we had in crisp relation, it was a mapping from x cross y Cartesian product to yours 0 and 1, 0 and 1 only. So, here let us extend, very simple, you know now fuzzy set. So, now this will be a relation, again R bar I am using due to fuzzy relation. R bar will be a mapping from x cross y to, now it is an interval 0 1. Okay? Now you understood the extension from crisp to fuzzy. Okay? Now I can write this R bar as also, we write like this, x, y and mu R bar x, y. This is just for writing the fuzzy relation, x, y, mu R bar x, y, where this, where also such that x, y belong to x cross y, where this mu R bar x, y is the membership function for this relation. Actually, this says the strength of the relation, strength of the relation. So, mu R bar x, y, where mu R bar x, y is the strength of the relation, which is the membership function. Okay, understood? From crisp to fuzzy relation. So, let us take one more example here and see how you write. You know although, but let us see. Okay. Suppose I have a set A, where we have the relation set A. I have suppose 3 points A, B, C, and suppose here D is also there. So, I have like these arrows. Okay. So, this is your crisp, means I have relation from C to A, I have relation A to B, I have relation B to C, I have relation C to D, but I do not have relation from B to A. So, I have, that means for crisp, R of AB as 1, okay, R of BC as 1, R of CA as 1, and R of CD as 1, others are 0. This is for crisp. Same thing if I have fuzzy. So, I have A, B, C, D. So, suppose I have A to B as 1.0, this may be 0.8, this may be 0.5, this may be 0.2. So, here for this is fuzzy. Okay. So, I have R bar of AB as 1.0, R bar of CA BC is 0.5, R bar of CA is 0.8 and R bar of CD as 0.2. Now, if I want to have the relation A cross A itself, A cross A, this is A cross A. So, I may have the relation matrix for crisp and fuzzy. So, for this crisp I have the relation A B C D, A B C D. So, A to A is 0, A to B is 1, A to C is 0 or not, A to D is 0, B to A 0, B to B 0, B to C 1, like that you can complete very easily. Similarly, here it will be little bit change and R bar will be A B C D, A B C D. Okay. So, this will be what? A to A is 0. So, if I have suppose like this itself, then it will be something. Okay. A to A 0, A to B is 1, A to C is 0, A to D is 0 and B to A is 0, B to B is 0, B to C 0.5, B to D 0. So, like that again you can complete this. So, this is the difference between relation matrix between crisp relation and fuzzy relation. Very easy or not? So, these are having many applications that I told already, temperature and pressure. I want to have relation between temperature and pressure for some output. I have temperature 3 suppose. Okay, let me just suppose I have temperature for 3.x1, x2, x3 and I have suppose you have these are fuzzy, okay, 0.8, 0.6, 0.5. These are membership functions for these temperatures. Okay. Then suppose I have pressure, maybe I have 2 values. Okay. So, I take suppose 0.2 or 0.5 and 0.7 maybe. Okay. So, I want temperature pressure relation. So, we will see, I will take later actual examples, practical examples. So, temperature pressure relation. So, this temperature I can write this R bar, this I can write as column vector membership functions 0.8, 0.6, 0.5 and this pressure I can write as 0.5, 0.7 and then this is your 3 by 1 and this will be 2 by 1 by 2. So, you can generate then 3 by 2 relations, this matrix, relation matrix that I will show later how to generate for these temperature pressure relations. So, like that you can have the relations and you can have the output accordingly. Okay? Now, here also in fuzzy relation also you have some operations, same union, intersection and complement, very easy, you can very well extend. Okay? Operations. Suppose I define first intersection. So, if it is intersection, this is operation, binary operation. So, I should have 2 relations. No, then only I can define intersection. So, if R bar and S bar are 2 relations, okay, then I can have membership function for this mu R bar intersection S bar x y. Okay, remember in the Cartesian product x cross y. Okay, so this I will define how? Very simple, minimum of mu R bar x y and mu S bar x y, same whatever you have read for intersection. Similarly, I can write for union, it will be mu R bar union S bar at x y is equal to, now it will be maximum of mu r bar x y and mu s bar. Okay. We can also define complement. Suppose r bar is a relation, so I have the complement, r bar complement at x y, and you know how to define, it is 1 minus mu r bar x y. Okay. So, with this we will close today. All these operations you just see. Tomorrow we will do more on fuzzy relations. Thank you.